Hi, I'm Adam.
My name's Etta.
And I'm Akshay.
We're working on the lunar sample return box.
So our plan for the sample box tubes themselves is to use the anodized titanium tube with metal alloy plug to prevent leakage of the gases and prevent contamination of the samples themselves. The metal alloy plug has performed well for the helium leak test with both a clean and dirty seal.
For the actual container of that will contain the tubes with the lunar samples inside is going to be multiple layers to it. So our first layer is going to be like an outer protection. The outer layer of the box will look like the original lunar sample return box with the over-center latches, and the material of the box will be anodized titanium with a double metal knife edge seal. The second layer is going to be for structural purposes. It's going to be like a honeycomb aluminum structure. The third layer is going to be for thermal resistance. The use of aerogel insulator will be the most productive to prevent the samples being exposed to temperature changes. Due to fragility and aerogel, a carbon-enforced aerogel will be best. Fourth layer will be for cradle purposes. It's going to be a wire mesh rope anti-vibration mount to prevent G-forces and impact forces on the samples. And the fifth and final layer is going to be a metal mesh layer around to surround the tubes as a final prevention for impacts and vibrations.
For thermal resistance, we will use carbon-enforced aerogel. Why we're going to use this is that it exhibits low density to high strength, robust elasticity, and fatigue resistance, with a permanent deformation of only after 100 cycles, and it maintains low thermal conductivity and high thermal stability up to 1200 degrees Celsius, as well as low thermal conductivity and good mechanical properties. As well, we're going to be using titanium because of its enhanced corrosion resistance and wear protection and lubricity. We will use anodized titanium as our main material for the body. The anodization process creates a protective oxidized layer that will prevent cold welding, which is a risk if we use titanium with titanium being present on the lunar surface. Anodized titanium will be the main material used in the box to provide structure, and the titanium will be used on the outer shell of the box. Our questions for NASA are: how large of the samples will you need? What are the constraints for the weight? And how should we power the mechanisms? And also, how large can this be? Thank you. That is all.